comparatively less, right? So that is the advantage. Okay. So how ML fits in science? So usually while doing machine learning or for leveraging machine learning on complex data for scientific discovery, we will use pattern recognition, okay, simulation surrogate, generative design, and reinforcement learning for optimization. These are the major tasks we are performing on complex data with machine learning for scientific discovery. Okay, so if you see, suppose you want to explore any of the machine learning paradigm, okay, in any of the machine learning paradigm for a scientific discovery, we can actually really fix which paradigm should be used based on the objective we have as well as the data we have, right? So if you have objective of discover something, okay, you want to discover something, and you have a labeled data, right? You have a labeled data, then you can go for what supervised learning, and usually we will perform predictions, the prediction task. We will do the predictive analytics with supervised learning. Okay. And if you don't have the labels, okay, if you don't have the labels, that is the label for the data is unknown, and you have an objective of discover something, you can actually utilize unsupervised learning for doing it. Okay, unsupervised learning for doing it. So unsupervised learning will identify the hidden pattern within the data without even having the labels marked with it, right? And if your objective is to control something, okay, control a task, and you don't have any kind of labels, then you can go for generative machine learning models to create content, okay, to create content. And if your objective is to make control on labeled data, if you have a labeled data and you want to make a control on it, you can actually go for reinforcement learning. Okay, so based on the objective as well as the data we have, we can actually use different kind of machine learning techniques to perform a particular or to solve a particular problem in the domain. Okay. So what is actually generative model and discriminative model? What is the difference in generative versus discriminative? A generative model is nothing but, see, if you give an input, that model will be able to create some output based on the input. Okay, it will generate some kind of output based on the input. See, suppose you are giving the image of a dog, and the model is actually outputting another image, which will be describing how this dog will appear after 5 years. Okay, a puppy will appear after 5 years. What will be the appearance of that dog? So there, what is happening is, on giving a particular input, the machine learning model is able to output or generate some content itself, right? But in the case of discriminative models, it is usually used for decision making. Okay, it is usually used for decision making. As an example, see, you may be familiar with the face detection in your mobile phones, right? What is the thing happening with that face detection? On giving a particular face, the model will be able to predict whether it is a valid face or not, right? Valid face or not, right? And maybe you heard about different machine learning techniques used for disease diagnosis, right? Diagnosis. So on giving a particular CT scan image, it will make a prediction that whether that image is having a cancerous present or not, right? So in that cases, we are making a decision on the particular input, but in generative model, we are actually creating some kind of output from the input, right? So hope it is clear for you, right? So can you tell me what kind of model we are using in ChatGPT? Is it discriminative or generative?
Generative.
Yeah, it is particularly a generative model because we are giving a text and it will generate some output based on it, right?
Yes.
So can you tell me what kind of AI is Google Translate? Google Translate?
No idea.
What is happening with Google Translate? You're giving a particular text on a text with on a particular language as an input. You will get another language text as an output, right? So is that
Yes.
generating or discriminating?
The input is given as text, so it might be generated.
Yeah, it is also generated, right? And see, maybe on typing a particular word, you will get some spelling correction indications in MS Office or even in our mobile phones, right?
Yes.
So what kind of AI is that?
Generated.
On giving a particular word, it will predict whether it is correct or not. What is that? You just think
It is predicting, so it may be
it is discriminating.
discriminated.
Yeah. So the mask detection, whether a person is wearing a mask or not, it is also discriminative, right? So hope you
Yes.
got the idea of what is generative and what is discriminative, right? Okay.
Yes.
So
Yes.
this kind of things can be leveraged for different scientific discoveries. And I am showing a simple example. See, I'm giving a text. The research introduced a new neural network model that outperform existing approaches in machine in image classification. Okay. So if this is classified as an AI research or an ML paper, it is a discriminative task. Or if we are creating the summary of this particular document, what is this? This is a generative model. Hope it is clear, right? What is generative and what is discriminative?
Yes.
Yes. And see, when we are talking about the breakthroughs in machine learning, so it is not actually possible without a very prominent family of algorithms within machine learning, which is called as artificial neural networks. Okay, artificial neural networks. So artificial neural networks are actually nothing but they are a family of machine learning models. Okay, which depicts the human nervous system as well as the brain. Okay, which depicts the human nervous system as well as the brain. Okay, for making decisions and even to generate contents. Okay, so neural networks are flexible function approximators inspired from biological neurons, and they are actually a prominent ML family. And this neural networks are actually the seed of what we are experiencing as a magic now, the ChatGPT, right? A ChatGPT is a product, a machine learning product or an AI product which is coming under the family of neural networks, right? So the neural networks are actually defined in a very particular hierarchy. The simple and very useful neural network model which is utilized for different linearly separable problems and linear approximation is actually called as a perceptron. Okay, perceptron. Okay, you can actually consider this x1, x2, x3 as a neuron inputs, and this itself as a neuron. Okay, this itself as a neuron, and this is the output from the neuron. So from the axons, it will receive output inputs, and sorry, from the dendroids, it will receive inputs and it will process it in the nucleus and it will output the signals to axons, right? So this is the simplest model, and this model is actually having a lot of limitations. Most of the machine learning problems cannot be solved with this perceptron. Okay, so as a remedy for that, or a replacement of perceptron, the scientists were introduced another kind of neural network which is called as a multi-layer perceptron. Okay, multi-layer perceptron. And in this multi-layer perceptron, you can simply think this x1, x2, x3, x4 are our or we can simply say these are the organs that receives the inputs, right? Receives the inputs. And this is what we are calling as a hidden layer, right? Hidden layer. And these hidden layers are actually depicting our process happening in our brain. Okay, and the thinking process will happen on the hidden layers, and this hidden layers will finally output something based on the inputs x1, x2, x3, x4 after a thinking process, right? So this structure is actually depicting our human nervous system, and this is particularly called as multi-layer perceptron. And can you just see what is the difference between these two images, the first image and the second image? Will you be able to understand what is the difference?
Multiple layers we have. Hidden
Yeah,
multiple layers we
yeah. In the first network, we can actually see that there are more than one hidden layer, right?
have.
So
Yes.
more than one hidden layer, but there are multiple hidden layers. But in the second image, it is only one, right? So
Yes.
as I said, if you relate these hidden layers with our brain, what is the capability of the first network? The brain is more deeper, and the thinking process happening on our brain is more deeper fashion, right? And the second one is actually called as a shallow neural network. Both are multi-layer perceptron, but the one is actually called as a shallow neural network, and the first one is actually called as a dense neural network. Okay, why it is called as dense? If the number of hidden layers are more than or equal to three, okay, if the number of hidden layers are more than or equal to three, it is actually not a criteria or something. People or different scientists experience that if we are having more than three hidden layers, it will work in a deeper way. That is why we are telling that if a neural network is having more than three hidden layers, we can view it as a deep neural network. Okay, deep neural network. And these deep neural networks actually accelerated a very new and very wonderful domain in machine learning, subdomain in machine learning, which is called as deep learning. So in the deep learning techniques, what is happening is, see, the input is actually learned by the network itself. See, in the case of simple neural networks or simple machine learning, the inputs need to be given into or given into a feature extraction step, and we have to extract the features, then only we can apply it into a machine learning model. But in the case of deep neural network, the model itself is capable of identifying what are the good features for making a decision based on the input, right? So feature extraction is not happening in deep learning, so that this is more flexible for any kind of data. And there are majorly two different kind of neural networks we use for deep learning. First one is to handle the spatial data. Spatial data is nothing but you can consider an image as a spatial data, right? Image as a spatial data. So handling such kind of spatial data, we are always using a network, a kind of deep neural network called convolutional neural network, right? And the second kind of neural networks we are actually using for sequential data is called as recurrent neural networks or long short-term memories. Both are actually coming under the same family. So what do you mean by sequential data? What is the significance of sequential data? So I will give you an example. See, suppose I am telling that I'm thinking about a sentence in my mind. Okay, thinking about a sentence in my mind, and that sentence includes words like I love, hate, terrorism, India, but. Can you tell me whether it is a positive sentence or a negative sentence? I love, hate, terrorism, India, but.
I love
Sir, you
India.
love
And
India and
but
you hate terrorism.
It can also be another way, right? I love
yes.
terrorism. I hate India. That can also be
Yes,
possible, right? So,
yes, sir.
what matter there is the unit informations are given to you, but still you are not able to con- get the context, right? So for getting the context, what will happen? What we need to keep? We need to keep the sequential arrangement of our unit information. So such kind of sequential arrangement can be handled with this family called recurrent neural networks or LSTM, right? So and what is behind the ChatGPT? So we are all using ChatGPT, right? So there is another kind of neural network which is utilizing a very prominent mechanism called attention mechanism for sequential data is actually called as transformers. So this transformer architecture are actually the the what core of ChatGPT you are now experiencing. This transformer architectures are capable of generating the output for a particular query you are giving to it, right? So this is an overview of how the machine learning techniques as well as the deep learning techniques are actually arranged in a technology space. So for dedicated kind of inputs, suppose you are having a tabular data or a classical data, you can go for multi-layer perceptron. For images or spatial data, we can go for convolutional neural network. For textual data or time series data or even sequential data, we can use for RNN, LSTM or transformers. For generative models, there are another kind of neural networks or variational encoders, uh, generative adversarial networks, diffusion models. A lot of family of algorithms are available for us. So, as an as a uh, as a what user of AI and machine learning, maybe you are from different domains like civil engineering or physics or social science or chemistry, mathematics, whatever domain you are from. Okay, as a consumer of machine learning or artificial intelligence, what matters is you have to know about your data and what is your objective. Okay, what is your objective? You have to know about your data and what is your objective. Based on that understanding, you can actually select any of the algorithms available for us for utilizing it for your analysis, right? And there is no need to create a new algorithm or something like that, because you are just applying machine learning or you are just applying machine learning or AI for solving your problems, not to find a new algorithm, right? So know your data first and understand about what is your objective, right? Based on that, you can actually select your machine learning model or a deep learning model for your purpose, right? And the key concepts we have this